thanks for having me today. I'm here to talk a bit about how AI development tools are really kind of starting to dramatically change the way we all write software, and really starting to strain the way that we all release software, and strain a lot of the traditional release processes that we've all used for and relied on for many years. And so, yeah, I have some thoughts on how feature flags can play a role in making sense of it all, and help tame the AI development chaos that I think is coming for all of us in different ways. And this is very delayed, but hopefully it switches. No? Classic. Oh, there we go. Okay, hopefully this works. Who am I? Jonathan Norris, as Todd said, co-founder and CTO at DevCycle. We did the company, our first product was called Tabletics. We did YC back in 2014, so like over a decade ago, which is crazy. Still been running the same company since then. We've been in the sort of A/B testing and feature flag space for that whole time, so over 10 years in building different products and solutions in that space. And I've been on the OpenFeature governance board for almost 2 years. So yeah, I've been involved in the project for a while. Us at DevCycle, we're strong supporters of OpenFeature and built a couple things like the multi-provider and a couple other features for OpenFeature and strongly support it. I'm trying something a little different today, and hopefully this works. Come on, you can animate. No? Oh, why are we failing? There we go. Okay, I am trying a theme to my slides today, which I think you'll all enjoy. It's the first time I'm trying this. We'll see how it works, but you'll see a bit of a Lego theme to all of my slides today. So for anyone who's been keeping up with the progress of AI models over the last couple of years, like, it's pretty clear that they've gone from toys to tools pretty quickly. Like, in the early days, these things were cool toys to play around with, but they've quickly, in the last probably 12 months, have gone to the point where they've become essential parts of many teams' development workflows, and as I think everyone knows, it's only going to grow from here. You may still be one of those engineers who has their heads in the sand a little bit, and don't believe that there's real productivity gains from working with these tooling, but I'm going to try to convince you a little bit that it can be. I think there's a bit of a misconception that, oh, it's only like junior developers or vibe coding hackers who are getting a lot of value out of this stuff, and I don't think that's actually true. I think from my experience, I've generally seen that senior engineers who actually understand their systems architectures, can clearly communicate to other people and their AIs what they want changed and how their systems work and what their stylings are, can actually use these tools to multiply their efforts more efficiently and effectively than sort of junior engineers and vibe coders can. And so it's actually, if you're a senior engineer, you're actually the ones who probably should be investing more in it than I would say a junior engineer should be. And it's pretty obvious that the rate of the improvement of these models over the last 18 months has been pretty eye-opening. I would say the rate of the top-level intelligence of these models has leveled off a little bit over the last release cycle, but there's some really exciting enhancements of that. Actually, the speed of super effective and close to top-level intelligence models has gotten really, really fast, which I think unlocks a lot more behaviors than the really slow top-level intelligence models do. But yeah. This is the only slide I have that doesn't have Lego on it. I tried to make this chart out of Lego, but it was too complicated. This is a chart from one of my favorite websites that helps track the pace of model development. It's called artificialanalysis.ai. And you can kind of see the track of sort of model intelligence improvement over time using this chart. And you can see that a lot of these sort of mostly Chinese open source, open weight models from labs like ZAI and DeepSeek and people like that are catching up to the raw sort of intelligence from the more known model providers like OpenAI and Anthropic. And one of the things I've learned in my use of these models is that you actually need to learn what the right model for the right job is. And this is something I'll be coming back to a lot, is that there's certain models that are good for certain tasks. Like if you're working on a really hard problem, like you're debugging a really, really nasty bug, or you're trying to do a deep, like help use an AI model to plan out a complex feature build, there's certain models that are slow and smarter, things like GPT-5 and Opus and Codex and things like that that might be good for those use cases. But there's also, you need to learn how those different models work. So some models are very to the point. Like GPT-5 will only do the things you tell it to. And then there's other models, like if you've ever used a Grok model, which will go off on the deep end and just do wild things that you didn't tell it to do at all. So you have to learn sort of the intricacies of how the different models work and how to make them work right for your different use cases. And then there's other models which I will say are probably the better defaults that are good sort of all-arounders, like the Anthropic Sonnet models are a good sort of all-around model. And I've been most excited by the new, faster sort of open weight models that are being released by some of these Chinese labs have led to some really interesting innovations. And I'll get into a bit of how these innovations are being done. But in the last couple weeks, both Cursor and Windsurf, two creators of sort of AI IDE platforms, have launched new models called Composer 1 and SWE 1.5 that are basically just reinforcement learning trained on top of these open weight Chinese models. And so basically what they took is they took their internal data about how people are using Cursor and Windsurf to basically tune these really smart open source Chinese models to their specific use cases. And then they're able to serve them at, like, I've seen at least 4x, sometimes up to 10x faster response times and throughput than you get from OpenAI or the Anthropic models, which really, like, in your day-to-day, it really dramatically changes how well you can work with these models. Like I actually personally went through a rut of sort of like struggling to use AI in my development workflow because I was trying to rely on like the super fast, hyped GPT-5 model that just came out, but it was just so slow. I found myself getting distracted by Slack or Twitter or things like that like it actually just demolished my productivity. And so, yeah, now that these new models can produce hundreds of lines of code in seconds and can search through your code base like dramatically faster than some of the standard models can, for me, it's been just a massive increase and really made me like sort of believe in the power and where these models are going. So it's clear that the pace of these are increasing and that there's two main sort of paths that teams are going down. The smart enough and super fast models for sort of AI pair programming use cases, and the really smart, slow use cases for things that I'll get into more sort of like background tasks. So yeah, I personally like to call these AI IDEs and CLIs AI pair programmers. So that's kind of how I think about them. You're sort of working hand in hand with these AIs to build features. Sometimes that means that like you're instructing it to write all of the code for you, or other times you're sort of correcting it. You're like doing, like, if you've ever done pair programming with like a junior engineer, which I've done in the past, like you spend a lot of time teaching and talking through problems with the person you're pair programming with. And I think the best way to use these models and in these AI IDEs or CLIs is try to treat it like a pair programmer. And that forces you to actually give it more context and be clearer with your instructions of what you're trying to get done, which can really help you in certain ways. Like for me, that's helped give the AI enough context that I don't really write like Git commits anymore or Git PRs because my AI has so much context about what we've been working on. Generally, it's 90% of the time, it's writing the correct Git commits and generating a good starting point for a PR description for me that obviously I usually do some editing on, but it's really made that process of writing commits and creating PRs much faster. So yeah, and I think the important thing is like keeping you in the context. Like as a developer of a feature flagging platform, I'm constantly switching contexts between like an edge API to a backend service to trying to create a feature across different SDKs. Like there's many times where I'm creating a feature for our SDKs and working across like 5 different languages a day. And that's really hard to do as a developer. And working with AI and getting good at that has really empowered me to be like, okay, I'm gonna go build this feature in one language, and then I get the AI to describe, what did we do? How did we solve this problem? What were some of the challenges we face, and output that. And then I can go to, say, the Java repo or the Go repo and provide those instructions to the AI agent in those repos, and really, really helps me get the job done in those other repos a lot faster, because before it would take me like a day to get context again of like, oh, how do we structure the Go SDK, and like, how does the syntax work? Like, it really, those problems were really slowing us down. And now, for me personally, it's really unlocked our ability to work across different stacks and code bases. Yeah, and then as I talked about, using the right model for the job can be a big unlock as well. So. And then, so if AI-powered IDEs are an AI programmer, it's clear that background agents are kind of designed to steal work away from you and automate your job. Like, it's pretty clear that that's where these things are going. I don't think we have to be too worried just yet. Like, I think most people who've played with these background agents, that they've been a lot less successful than sort of the AI IDEs and CLIs. They're probably below 50%. They're probably at below 50% like success rate to date. They're good if you have a simple thing like a refactor, updating tests, updating dependencies. If you have something that the AI agent can loop over, then it's pretty successful. Like, hey, I have these set of failing tests. Please loop over this and solve it. It's pretty good at that, but otherwise it's a little rough right now. But I think the more interesting thing is learning of like, why are these companies investing so much time building these AI background agents? It's not just to take work away from you and take your job. It's also that they're using these background agents to do the reinforcement learning for their models. So OpenAI, Cursor, Windsurf, all of their background agents are actually what they're using behind the scenes to run reinforcement learning, which is basically, say you run one of these Chinese models against a real programming job, usually against some open source software, and then you basically measure the success of that result and basically tell the model, hey, what you did in this run was good or bad, and it does basically weight-based reinforcement learning to increase the performance of these models. So I actually think there's probably far more workloads going on for reinforcement learning using these background agents than real-world work right now. But that is actually what they're being used for. But in the future, if they get good enough, they are trying to take your job by just saying, hey, here's a spec for a feature, robot, go build it. That's where they're trying to get to. And here's like an outline of sort of all the roles that AI are taking in the current modern development workflow. We've talked about the AI pair programmer and background agents, but if you haven't used code review agents, they've gotten really good in the last 6 months using the new models. They've done, obviously, a lot of training and tuning of those agents. They were really bad when they first launched. Like, I tried to enable them, and they were super verbose and unhelpful, and they were just a mess. But they've gotten really good in the last couple months. Similarly, AI security review agents, another kind of flavor of the code review agents, have gotten pretty solid. If you aren't using an automated dependency management system, if you have a large sort of JavaScript project, like, are you a masochist? Like, it is like a nightmare out there. So use some automation and potentially AI automation to help you there. And then AI-powered bug fixing tools have gotten really interesting. If you haven't played with Sentry's Seer AI, it is pretty amazing. Like, obviously, Sentry is a good platform for error tracking and logging and things like that. But they've combined all that with an AI agent that can understand the context about the error that's happening and then actually make a PR to go fix the bug in your repo automatically, kind of hands off. And it's one of the most, like, it was one of those eye-opening things that I went and tried, and I was like, oh my God, like, yes, like, this is a clear example of AI providing real value to developers and automatically solving problems for us. Yeah, and then as we'll talk about a bit more coming up, AI-powered code deployment systems are the future, and they're coming to manage all your feature flags. So I think it's becoming clear that as code becomes cheaper and cheaper to write, the real bottleneck is actually releasing code to production. Most engineering teams are really held back by the release process that can take days to release software. And as an engineering leader, you kind of don't want your teams spending that much time reviewing code and testing and shepherding releases. So some of the results I've seen some surveys is that one survey found that teams using AI coding assistants are dealing with 47% more pull requests per day, and 63% of organizations are shipping code faster to production with AI coding tools. But also 45% of deployments with AI code are leading to some problems and failures in production. So slower kind of big bang releases and long QA cycles really can't keep up with the volume of speed of these changes. And this is leading to a slow resurgence in the adoption of continuous deployment. But the reality is only 6% of companies have fully automated deployments starting as early as this year. And in a survey that was done for this, a lot of leaders noted that design reviews, PR queues, test failures, context switching, and waiting on deployments are the real bottlenecks of releasing software to production these days. So even though continuous deployment's been around for a while, AI is really accelerating, I think, the move towards it, and we're only going to see a rise in that over time. And so it's going to be a bit funny, but I think the real reasons why organizations are going to start to adopt continuous deployment and actually take action to get everything in place to do that is because of AI-driven development. And yeah, for any team that's adopted continuous deployment for real, we've been using it for over 5 years ourselves, it's pretty clear pretty quickly that you need feature flags as a required tool for true progressive delivery. And the unsexy truth as an engineering manager is that most developers are really bad at PR reviews. It's really hard to set up the incentives properly for an engineering team. They care as much about doing a good PR review as they care about writing their own code and shipping their own features to production. So the truth is that most engineers and most teams are not actually that good at PR reviews, which means that a lot of times you are shipping code that isn't 100% certain to work in production. And obviously testing is a big part of that, but properly using feature flags as kill switches is super essential to doing smaller, more iterative continuous deployments to production. And I've personally seen it from some of the world's largest banks to some of the tiniest startups. Once you implement proper feature flagging where you're gating your releases to production, it will save your ass at some point. I've seen millions of dollars, tens of millions of dollars saved by teams that have properly implemented feature flags. And yes, there is cost to doing that, though AI is bringing that down. It will save your butt at some point in the future. And any team that's trying to move and deliver software more quickly should be doing it. I think one of the most interesting developments is that AI companies themselves have actually been probably the leading users of feature flagging for their products. They're probably the biggest users at scale of feature flags and continuous deployment. Not only the number of flags they have in their code, but obviously the hundreds of millions of users who are using their platforms. And they believe it in so much that OpenAI recently purchased DevCycle, right? And they're basically purchased one of their co-founders to lead product development at OpenAI. So it's pretty clear that it's a key part of how they're delivering software. And I think it's clear to everyone that the pace at which companies like OpenAI and other AI labs are shipping software to production over the last year is pretty incredible. When you just think about the products they've released, from their codex tools to their image generation tools to their social experiments, the pace of product releases is pretty incredible, and all of that is driven by feature flags and progressive delivery, and obviously their AI coding tools. So when you actually interact with some of these people at these companies, and it's pretty easy these days to do on Twitter or X or whatever we call it, it's no secret that like most of these projects are started by a small group of senior engineers. So like you might think something like Codex or their background agents or even Claude Code is like some big team behind it that's building this crazy CLI, but it's actually a group of like 3 or 4 like obviously super smart, but like senior engineers working together using AI development tools to produce these products. And yes, like obviously those teams expand once they get to production, but they're building these whole new CLIs and tools internally at OpenAI and other companies using only a handful of engineers in a handful of months. And because 70 to 90% of their code is generated using their own tools. So like they're probably the best example of where things are going and what we all need to do to catch up to the pace of product development that's coming down the pipe. Yeah, and when I put on a bit of my Lego crystal ball of like where things are going, I think in the feature flagging market specifically, there's obviously been a lot of consolidation in this market over the last year or so, and like previously, things like product experimentation were really driving a lot of the investments and VC money and things like that in the industry. But I think there's a wider opportunity in this market for feature flags that are powered by smart observability platforms, and where changes made by AI can be monitored by observability platforms that have deep integration into the code that's running, and can manage sort of the rollout of these new features and these feature flags in real time. And so rollout percentages will be controlled by the robots sort of monitoring your metrics, and will be deeply tied to how the feature flags are rolled out. AI will likely play a role in the decision-making process of rolling back and forward new releases. And as any team that's like adopted feature flags at scale, like managing releases across hundreds of flags that are in production is a really daunting task today. And I think that AI tools can help make sense of that chaos and probably do a better job than humans can in the near term of managing sort of hundreds of flags that are in production. So I think this is where things are going pretty clearly over the next couple years. And I think almost more importantly, I think existing CI/CD systems are probably, most of them are going to have to get rebuilt. So currently, I think that stat of only 6% of companies using CD or continuous deployment obviously is going to increase. But currently, the average CI/CD sort of pipeline takes over 11 minutes to get to fully sort of test and deploy changes, which is, in my world, is actually, I think that's pretty slow. And I think where a lot of that work is going to shift from a CI/CD system actually down local to your computer. So I don't think most people realize, but if you have like an M-series Mac, it is the fastest single-threaded processor in the world, right? There aren't server CPUs that are as fast as you're like running your tests and your linting and things like that locally on your computer. And there are companies that are trying to use like high gigahertz gaming CPUs to do something similar, but your computer is actually the fastest place where you can run your tests, your lints, your validations. And so where I think a lot of these platforms are going to go is probably like using cryptographic signatures to like sign that you've run sort of your tests and your linting and things like that with the right configurations locally on your computer, and we're not going to have to wait on CI/CD builds anymore. Because the reason why you want to bring it down local, because then those tests and those linting and all that stuff can be obviously deeply integrated with your AI development workflow that's mostly happening locally or in your background agent. So I really think a lot of existing CI/CD systems are going to be blown up, and there's going to be a push to bring a lot of that stuff down locally to your development environment. Yeah, and then I think it's clear that a lot of code will start to be shipped to production without humans ever reviewing it. I think the AI code review systems have gotten good. They understand, they can spot a lot of simple problems. And I think they can very quickly in the near future understand what's the risk level of this PR, and can we do a good enough AI code review, and we know that it's properly gated by a feature flag, which I think is a very important thing. We can automatically ship this code to production without a human reviewing it. I think there's probably teams already doing this, and I think this is going to become a more common practice over the coming years, and a lot of people are going to be uncomfortable with it. And then finally, to sort of wrap up, the only thing I can guarantee is that deploying AI-developed software is here to stay. These are no longer toys. They're clearly tools that, when learned, can dramatically improve your developer's velocity. Just like modern IDEs, smart autocomplete, real-time type checking, and linting provided a lot of benefits to engineering workflows, AI assisted development's sort of not going anywhere. And I think it's also clear that there's a lot of executives out there running engineering organizations without clear intentions and proper plans that are going to continue to push teams to adopt this stuff, right? And so instead of being an engineer who sticks your head in the sand and fights against it, I encourage you to sort of adopt where things are going, because there's a lot of interesting technical problems to be solved by actually figuring out how to sort of re-engineer a lot of these systems and processes to deliver this software effectively to production. So yeah, and then as an engineer, there's nothing really more motivating than seeing your code that you just wrote used by customers in production, and the faster you can get that done, the better. So yeah, a lot of existing release processes and systems are going to be destroyed by all this, but I think that also means there's a massive opportunity to reinvent these processes for a future that actually embraces AI code development. So thank you.